Welcome, everybody. Today we're going to continue practicing solving systems of equations using substitution, but we're going to look at the cases where there's no solution or infinite solutions as well, which you might remember when you graph. No solution means the lines are parallel, and infinite solutions, the lines are the same exact line. So we will look at that as part of this lesson, but we'll do some more practice because this can be a tricky section, and you'll have a test tomorrow. Okay, so let's solve the following system algebraically. So you will notice that we have not solved for y or x here. So that's going to be the first step. So we pick one of the equations. And you either solve for x or for y. So I like this second equation because the x has no coefficient. Well, it does have a coefficient. What is it? It's 1. So that one will be easier to solve. So let's add 2y to both sides. That gives you 1x plus 0, cancels, equals 2y plus 10, or 10 plus 2y. And then that's it. You don't have to divide by anything. You could divide by 1, but you get the same thing. So now you take that equation and you plug that in place of x in the first one. Okay, so now you're going to get 3 parentheses. So now instead of x, you write 2y plus 10 plus 2y equals negative 12. So that's the part we just substituted. So now you see how that reduces the equation to just a y. So we can solve it like we did a couple months ago. So now you get 6y plus 30 plus 2y equals negative 12. So we just distributed. Now we can combine the like terms. 6y plus 2y is 8y plus 30 equals negative 12. Now we can subtract 30 to both sides. So that will give us 8y plus 0, cancels, equals now negative 12 plus negative 30 is negative 42. And then we will divide both sides by 8. Y equals, okay, so let's see, negative 42 over 8 would simplify to negative 21 over 4. So we could leave it like that. We could change that to a decimal or a mixed number. Let's do a decimal. So 21 divided by 4. So negative 5.25. Yes, you can have decimals. Okay, now we're not done. So now y equals negative 5.25. So now how do we get x? So you can come back up to this equation. You already solved for x, right? You could actually put it in any equation. Here, I'll write that. Put in any of the equations. However, the easiest will be this one up here because we already have x equals. So you come over here. So we'll say x equals 2 times the negative 5.25 plus 10. See, we just replaced y with negative 5.25. So now you get negative 10.5 plus 10 equals negative 0.5. So now there's your ordered pair. Let's write the ordered pair. So you get negative half, comma, negative 5.25. Now remember, a way to check is to plug in the negative 0.5 for x and the negative 5.25 for y. So let's see. So you take these numbers and put them in up here in both equations. And then you should see that they both work. So you take that time to check. And remember, what that means is when you graph these two lines, that's where they're going to intersect. Okay, these are examples taken right from IXL. Solve using substitution. So remember, you pick an equation to get y or x by itself. Okay, sometimes one will be solved. Most of the time one will be solved in this class. But you could, so let's see, you can pick either one, but look, this first one looks easier because you have a 1 coefficient with the y. So I'm going to rewrite it down here. And let's get the y by itself. So add x to both sides. So you get 0 plus y, or just y, equals x plus negative 10, or x minus 10. Okay. Now, we take wherever you see the y in the other equation, you replace it with the x minus 10. So you get negative 7x minus, in parentheses, always put it in parentheses, equals negative 14. So now you have a little distributive property going on, right? You have to distribute that negative sign. So we'll do that first. Here, I'm going to write that, distribute. So negative 7x, now here's the distribute, negative 1x, and then negative 1 times negative 10 is plus 10. What's next? Oh, combine like terms. So we have negative 7x plus negative 1x is negative 8x. And now solve the two-step equation. Minus 10 gives you negative 8x equals negative 24. Divide by negative 8. X equals 3. Okay, we're partially done. Now we want to get y. So you put it into any equation, but what's the easier equation? This one that you already solved for y. So y equals 3 minus 10. 3 minus 10, negative 7. You could still use your calculator if you need it. So write the ordered pair, 3, negative 7. And then you can always check. Negative 3 plus negative 7 equals negative 10. And then negative 7 times 3 is negative 21. Negative 21 minus negative 7 is negative 14, so it works. Go ahead and try this one. Ooh, this one's ugly. This will be under the challenge section of IXL. So pick either equation to solve for y. You can pause at any point if you want to get a head start. For no apparent reason, I'm just going to pick this first equation. Both of them stink when you want to get y by itself, but let's do it. So I'll write it over here. So negative 7x plus 9y equals 18. I'm going to solve for y. Okay, so we add 7x. Right? This is nothing new. It's just going to be a longer problem. 7x plus 18. And then what? Divide by the number next to y. Divide by 9. So that gives you 1y equals 7/9 x plus 18 over 9, which is 2. Okay. So now you have y alone. So when you see y in the other equation, see, it has to be the other equation, then you plug in that expression. All right, here we go. 8x minus 6 parentheses 7/9 x plus 2 equals 18. Oh, those fractions. You'll be fine. Okay. So now you get 8x, right? Distribute the negative 6. Negative, let's see, negative 42 over 9 x, right? Multiply fractions across. And then negative 6 times 2 is negative 12 equals 18. Okay. And here you may opt to use your calculator. So 8 minus 42 divided by 9. We're combining like terms. It's a little uglier, but it's still combining like terms. And you get 3 1/3, or 10/3. I used my calculator, if you're wondering how I got that. Okay, minus 12 equals 18. So that was 3 1/3. Yep. So now we add 12. We're getting x by itself. 10/3 x equals 30. Now we divide by the fraction. When you divide by a fraction, multiply by the reciprocal. So that gives you 1x equals 30 times 3 is 90, divided by 10 is 9. So we have x equals 9. We're not done, right? We got to get y. Find an equation where y is already solved. There it is. Again, it'll work for any equation, but you want to try to simplify. So y equals 7/9 times 9 plus 2. Again, you can use your calculator. Y equals 9. So your answer is 9, 9. Okay, so we're going to do a couple special ones here. So all the ones we've done had one solution, and I want to show you that's not always going to be the case. So watch here. So we have in part A, they're already solved for y. So you can substitute one expression in for the other. So we'll change this y to 3x plus 2. And then watch what happens. You want to get the x's to one side, so you subtract 3x to both sides. You get 2, so 0x is 0, plus 2, equals 0 again, minus 5. So 2 equals negative 5. What happened to the x? Well, the x's are gone. Look at this expression. Is this true or false? Of course, it's false. So what we said, when that happens, this ends up being no solution. Now, you might have known right away. Look at these equations. The slopes are the same, different y-intercepts. Those are parallel lines. So even though it didn't say to graph, you could have known right away no solution because they're parallel lines. But if you're doing the math, the substitution, and you end up no x's and you get a false statement, it's no solution. Parallel lines. So look at B. All right, so we solved. So here's y. So y equals this. We're going to plug it into the y in the other equation. Go ahead, try it out. Negative x plus 2, parentheses half x minus 4 equals 6. right? Put it in parentheses. That means distributive property. 2 times a half is 1. 2 times -4 is -8. Oh, there it is. There's the canceling action. X's are gone. -8 equals 6. No solution. So if you were to graph those, they would be parallel lines. Okay, let's look at this other option. So let's look. Okay, y equals 2x plus 4, y equals 4 plus 2x. You might have noticed something just now. Aren't they the same line? Right? Same slope, same y-intercept, same line. Watch what happens when we do the substitution. 2x plus 4 equals 4 plus 2x. Get rid of the 2x's, minus 2x. Oh, they cancel. 4 equals 4. True or false? True. So they're the same darn line. Infinite solutions. Yay. They're the same line if you graph them. So the whole thing is one big intersection. You just say infinite solutions. Okay, watch what happens over here. You could pause the video, try it yourself. So -2x plus 2 parentheses x minus 5 equals -10. Distributive property. Combine like terms. Oh, they're gone. -10. Yeah, see, that's still -10. Be careful there. Equals -10. True. Infinite solutions. So if it ends up true, it's infinite solutions. If it ends up false, no solution. So to summarize, if there is no solution, then the lines are parallel. If you use substitution, the x's cancel and you are left with a false expression like 3 equals 5. If there are infinite solutions and the lines overlap, if you use substitution, the x's cancel and you're left with a true expression like 0 equals 0. There you go. So you have an IXL for homework. I believe they all have one solution on the IXL, but on the next test, we'll probably throw one in that's no solution or infinite solutions. Have a great day. Take care.